Geometry 5.6 lesson on inequalities in one triangle. We're going to just jump right in. It says list the angles from smallest to largest. And so we have this triangle over here on the right. Well, they didn't give us the measure of the angles. They gave us the measure of the angle, measure of the sides. So I think you could probably figure this out. I'm going to hit pause and let you write down which angles you believe go from smallest to largest. So go ahead and do that. And so hopefully you wrote down angle R is the smallest, angle Q, and then angle P. And why is that true? And hopefully you're saying to yourself, well, it's because angle R is across from the smallest side, and angle Q is across from the next side, and angle P from the longest side. Well, why is that? Why is it that that's what happens? Well, let's just draw a little narrow angle, and if I drew a little small angle, guess what? You have a really short side. But if I draw a nice big wide angle, I end up with a big long side. And so you can see that if the wider your angle, larger your angle, the longer the side's going to be that connects the 2 points. So of course we have a theorem that discusses this, so let's just write that down. If 2 sides of one triangle are not congruent, then the larger angle is opposite the longer side. Okay, now let's look at example 2. It says list these sides from shortest to longest. And so again, they didn't give us the lengths of the sides this time. They gave us the angles, and we're missing angle K. But I know you could figure that out because you're so smart. Remember, the 3 angles of the triangle are going to add up to 180. So we can add 58 and 35 and take the difference from 180, and we get 87 degrees for angle K. So which sides are going to be smallest or shortest to longest? So we're just going to go from the smallest angle, and then the next smallest, and then to the largest. Bada bing, bada boom. So you're going to have LK, KM, and LM. So we have a theorem for that too. If 2 angles, I bet you could even write this out yourself without me walking you through it. If 2 angles in one triangle are not congruent, then the longer side is opposite the larger angle. Okay, so we're going to prove what is known as Theorem 552. If 2 angles of a triangle are not congruent, then the longer side is opposite the larger angle. So it's right here in example 3. And as it turns out, we're going to do that using some, indirect proof. That's what we learned yesterday. So we're going to use some indirect proof here. And remember that if we can come up with a contradiction to what we have here in our given, then we can say that we can prove our original statement is true. So, well, I kind of said that backwards. First, we're going to start with the opposite of this, which instead of having 2 angles where one is greater than the other, we're going to say, we're going to assume QR is equal to QP, in this case. And if we come up with a contradiction, then we can go back and say that our original assumption here is true. So let's try it. Assume that QR is equal to QP. So if QR is equal to QP, then we can say QR, I put the markings there for you, is congruent to QP by definition of congruent segments. And now that I'm writing this, I'm going to pause it for a second. Okay, I just kind of rewrote that so that we can look at our assumptions and our reasons like we do our regular proofs. It's easier for me to see, and hopefully it's easier for you too. So, okay, so again, QR, if we make an assumption that QR is equal to QP, then we can say that line segment QR is congruent to line segment QP by definition of congruent segments. And then if that were true, we could say that angle R is congruent to angle P. And how would that be? If two sides, go back to our isosceles theorem, if two sides of one triangle are congruent, then opposite angles are congruent. Okay, so if that's true, then the measure of angle R would be equal to the measure of angle P by what? Definition of congruent angles. But as we can see, once we've gotten to this point, that contradicts our given. Whoops. This contradicts the given that the measure of angle P is greater than the measure of angle R. Therefore, our assumption is false. This is false. And prove QR is greater than QP. The original prove. Okay, good. Let's look at example number 4. Okay, you should be able to answer angle 4 without any help from me. So I want you to do that. Please hit pause. List the angles from smallest to largest. Okay, so I hope you have listed down as your smallest angle, angle B, because here's the smallest side and it is across from angle B. And then I hope you have angle C, because here is the next side in length, and then finally angle A, because 9 is the biggest, and there's your largest angle. Okay, turn the page. Okay, so on number 5, you should be able to do this one without my help as well. So go ahead and list the sides from shortest to longest. Okay, so I hope you have written down XZ and then line segment YZ and then line segment XY, because we can see here is our smallest angle, 30, and it is across from XZ, and here's the next smallest is 40, and it is across from YZ, and then finally 110, and it is opposite XY. Okay, now I have a little theorem to give you, and it's going to help us in the examples that are below. So write this down, and we talked about this in class one time. We had a question that said, if you had an isosceles triangle with a perimeter of 18, what could be the possible side lengths? And remember, we had like 7, 7, 4, and we had 6, 6, 6. But remember, we got to where we couldn't do like 5, 5, or hang on a second. I think what we said was like you couldn't do 4, 4, 10, because if you had a triangle with 4 here and 4 here, 10's going to be way too big. So even if you stretch the 4 out to like this and like this, here is 4, here is 4, you still only have a side length of 8, and you'll never be able to make it match up to one with 10. So remember that? So anyway, I'm rambling. That was a couple days ago we did that. Anyway, here's the theorem. In a triangle, the sum of any two sides is greater than the third side. So basically what it's saying, pick any two sides you want on a triangle, add them up, and those two measurements are going to be greater than the third side. So why don't you look at example 6 and figure out for yourself which one of these could represent a triangle, A, B, C, 1, 2, or all of them. So hit pause and try that for yourself. So I hope when you did this little exercise you figured out that yes, A could be a triangle because 9 plus 10 is greater than 12, and I'm just taking the two shorter ones and we'll see if they're greater than the third one. So let's see here, 7 plus 8, is that greater than 15? No, so that one's not going to work. And 7 plus 10, is that greater than 19? No. So that's not going to work. So this one could be a triangle. Okay, so using this theorem, let's figure out the answer to number 7. The figure shows the approximate distances between cities in California. What is the range of distances from San Francisco to Oakland? So let's figure out what they could be. What could X be, the range from low to high? What could X be? So thinking about this, let's say, since first we want to see what it would be on the lowest side. So if X is the smallest of the distances of the three, then we know that that small distance plus the next highest distance needs to be greater than 51 based on our theorem. Any two sides of the triangle have to be greater than the third side. So, given that, take the two small ones have to be greater than the largest. So let's solve for this. Subtract 46. And so on the small end, x needs to be greater than 5. Now, what if x is going to be the largest distance? Well, in that case, if x is going to be the largest distance, then these two, when you add them up, 51 plus 46, they need to be greater than x. So the sum of these two sides still has to be greater than that other side that's going to be the longest. So we add those up and we say 97 needs to be greater than x. So if we were to write that as an inequality, we would say 5 needs to be less than x, and x needs to be less than 97. So the distance from San Francisco to Oakland must be greater than 5 and less than 97. Okay, good. Let's look at example 8. Okay, so on this example it says use the inequality AB plus AC is greater than BC to set up and solve a relationship between the sides of the triangle below. So basically this right here is going to be our final answer. So we're going to use this to set up our inequality that it wants us to do. So AB, so the measure of AB is 4x minus 4. Here, let's write it like this. AB plus AC needs to be greater than BC. Okay, so AB is 4x minus 4 plus AC, right here, 3x minus 2 needs to be greater than this one, CB, 5x minus 2. Okay, so let's go ahead and solve it. On the left side of our inequality, we have some like terms. So we have 7x minus 6 is greater than 5x minus 2. So we're going to subtract 5x from both sides. And we get 2x minus 6 is greater than negative 2. Add 6. And we got 2x is greater than 4. Divide by 2, and x is greater than 2. So, for this to work out, for the relationship of this triangle to work out, x must be greater than 2 for if we were to substitute x in here and have this triangle work out. Okay, so that is your lesson. And I'll see you in class. Looky there, under 20 minutes. Bada bing, bada boom. See you in class.